So I wanted to explain how to do number 4 on the practice test. Just looking at the answer key, it's not very easy to tell what's going on. So I'll do a different approach on this tutorial. What I'll do is, supposing if you're given an equation that's like f of x equals 3x plus 2. I guess I better erase this. So 3x plus 2. Okay, and you're asked to find the derivative, so want f prime of x. Okay, so if you want to look at the graph of this function here, it would look something like this. Okay, so this is x, this is y, the function looks like this. This is f of x. So the question that we are given, number 4, is you are given a graph, you're not given a function, so you have no idea what algebraically the function looks like. But I'm just treating this as an example, okay? So say if you are given this graph, okay, that's a straight line, and you know that the slope of this graph is the same everywhere. It's a 3, okay? So if you wanted to graph the derivative function of f, in other words, you want to graph this, then it's just going to be a graph that looks like that. So this is f prime of x. And you know, you could kind of differentiate this and find out that f prime of x is equal to 3, and then you're able to graph that. Well, the question on the practice is not quite like that. But the point I want to get across is that when it's asking you to graph f prime of x, it's asking you what is the slope of the graph at every point x on that graph. Okay, so let's take a look at this example here, okay, that we have. Let's see if I can, I'll get another one. Okay. So we've got a graph that looks like this. Okay, so this is f of x, this is x, this is y, okay? And you want the graph of f prime of x. Well, an alternative way of doing this would be to say, okay, let's take a look at the slope of the graph everywhere, okay? So if you look at the slope of the graph at this point, it's positive. It's some positive number, okay? Say it's equal to that number there. Then if you come out here, you can see that the tangent line has a smaller slope than what it is here, okay? So then the number is going to come down corresponding to this x value here, so it'd be out here. And if you went and analyzed that continuously, you would find that the derivative is becoming smaller and smaller until it becomes 0 at this point here, which corresponds to this tangent line. So for this part of the graph, f prime looks like this. Okay, that's f prime. Okay, and then you know that the slope of the graph is 0 at that point, so it should be there. Then if you take a look on the other side of the graph of f of x, you can see that the graph has a negative value all the way until it becomes 0 at that point. So at this point, f prime of x is going to go through 0. Out here, the slope is negative, which means your graph's going to come around here, and at some point it's going to turn the corner so that it goes up and becomes positive for this side here. So this is positive. So f prime will go up something like that. Okay? Right? So let me just choose a different color and I'll trace out the entire f prime graph. Okay? So the entire f prime graph is going to look something like this right there. You with me on that? So again, I think what you failed to see in class was that when I tell you that f prime of x is a positive number, I'm looking at the slope of the original graph of f of x. So for example, the slope of the graph at this point here is some positive quantity. Okay? It's some positive quantity. And it's going to be represented by the y value of this graph. So again, the blue graph here is really f prime. Okay, the blue graph is f prime. Let me do another example. Okay, let me see if I can get yet another template here. And let's try an example that looks like, what was in the class. So say something like this, okay? And I kind of try to use shortcuts in the class, but maybe that's not a good thing. So let's start all over again and talk about finding the slope of this function here, okay? So this function that we have here is f of x, okay? Is f of x, and what I want is f prime of x. Okay, that's what I want. So if I take a look at the slope of the graph at this point here, okay, it's positive, so it's going to have some number there. Then the slope is decreasing until the slope is 0 at, let's say, about here. Okay, so about here, f prime is going to go through a 0 there. Okay. So you get a feel that your graph's going to come down like this. Okay, your graph of f prime is going to come down like this. That's f prime of x. And then out here, the slope of the graph is negative until it is 0 out here. So your f prime function is going to go through there, which means it's going to come around and turn around. Out here, you can see that the slope of the graph is positive until at some point it goes through a 0 again. So goes positive, turns the corner around, and then you can see that the slope out here is all negative. So then it comes to a 0, which corresponds to this point here, where the tangent line is 0, and then it becomes negative. So the red graph is the graph of f prime of x. Okay, so I hope this kind of explains how you get number 4. And what if you were asked to find f double prime? Okay, what if you were asked to find f double prime? So let's go back again. Okay, and take a look at now the slope of this red graph. So you know that the slope of the red graph out here, if you want to draw a tangent line, the slope is 0. So f double prime is going to go through there. And out here again, the slope of that tangent line is 0, so it's going to come out here. All right? So taking a look at f prime on this side here, you can see that the answer is negative because the slope is negative on this side. So your graph's going to be coming from a negative number, crosses 0, and then you can see that the slope of the graph, or the red graph here, is positive, so it's going to go through a positive out there, and then it goes through a 0 there, and then comes back down again like that. Okay, so this would be f double prime of x. Okay, so I hope this explains how to graph this given a graphing function. Okay, bye.